That's a very common scenario that we would come across, where you've got different communications protocols or signals used, and then the role of our hardware and software would be to unify that data into a single communications link that you can make use of in the cloud, or to run whatever kind of model or logic on top of it. If we describe the sources of data, the first is industrial communications protocols. That could be something like Modbus or BACnet or OPC UA or whatever. These are kind of rich communications protocols where normally the gateway would communicate with a third-party system of some kind and pull out some or all of that data and expose it to the cloud. Another mechanism of getting data into the platform is through signals, and we have various wireless signal sensors, and that could be analog or digital signals like 0 to 10 volts or 4 to 20 milliamps or pulses or something like that. And then we have fully integrated products like our electricity meters or demand response controllers that can monitor three-phase power consumption very accurately, and about 50 other electrical parameters. And all of these things can coexist on the same system. So you can have data coming from third-party system, from industrial signals, and from our own devices, all kind of happily sitting on the same gateway or the same system. So the architecture of the system is at the lower level what we call nodes, and they can be physical or they can be virtual, in the sense that we're talking using a communications protocol like Modbus or something like that. Physical being our electricity meters. So you have many nodes connected to a single gateway, and then you've got EpiSensor Edge software running on the gateway, pulling all that data and then presenting it to where you want to consume it in the format that you want to consume it in. This is not a cloud service. We're connected directly into the web interface of an EpiSensor gateway here. So when you log in, you see a dashboard. It'll show you what hardware the software is running on, what gateway hardware that is, stats like the load on the system, the temperature of the system, how many nodes are connected, the operating system that's running, software versions, some controls to restart or shut down the system, etc. So you just get a brief overview of what's going on inside the system as soon as you log in. Then if I move over to nodes, you can see a list of nodes that are already joined to this system. This is a development system, but you have many nodes associated with each gateway, and each node then has many sensors or feeds of data associated with it. And you have a lot of control about how those sensors publish data, which are enabled or disabled or switched on or off or whatever. These sensors, some of them populate automatically. So this is a three-phase electricity meter from us. So you get about 50 sensors without doing anything, just by installing one of these products. There's a few functions, and we break it down into three different audiences. The first audience is a software developer audience. The software developer's role here is in getting data or translating data into exactly the format that you would want to consume it in. And that's slightly different for every software platform or every team. It could be JSON data over MQTT, or it could be some other format. But it gives software developers the capability to configure the feeds of data and the communications capabilities to match their software platform. And that works on the way up in terms of data arriving at a software platform in exactly the right format. And it also works to translate data. You might send a command, for example, to dispatch an asset or something like that. Maybe you're working with different hardware devices. Maybe you have some established protocol or syntax or whatever for that command. The role of the software developer in working with Edge is to interpret a command in a particular format that may already have been decided from a third-party software platform, and translate that and execute that locally to take some action. It's a mapping function between existing software platforms and the EpiSensor APIs, or how you would control different things. The second audience is for install teams. There is a need to install and commission systems that communicate with these assets, like the electrical installation, the wireless sensor network setup, etc. And Generally, those install teams want the minimum amount of information they need in order to make sure the system is installed properly and then pack up the van and move on to the next site. There is a role for Edge to surface only the most important information about how the system communicates with the software platform it's working with. So this is an example of one partner dashboard that is specific to their cloud, that shows things like when the certificates expire and if the connection is online and if there's a trip in progress and various other things like that, and then can expose commands that are specific to that platform, and that could be to register the system with the software platform or whatever. Just to summarize that again, there's functionality in Edge in the Gateway software to show install teams only the information they need to confirm that an installation is good and that the system is working properly. That's the second audience. And the third audience is for operations teams. Their job is to ensure that the system is running properly over time. They're interested in performance, latency, the state of a system, whether it's been dispatched or not, whether there's issues with wireless signal strength or communications or whatever else. So they're the three audiences that Edge serves. Okay, so we have nodes here, and you can add nodes to the system. As I said, they can be over wireless communications protocols, industrial comms protocols like Modbus or whatever, industrial signal sensors, the hardware devices that we produce. The process of adding a node, let's say it's a Zigbee node, you would open up the network for a period of time, and that puts the system into a scanning mode. Then you would press a button on a battery powered device or power up a mains powered device, and it will pop into the list here and it will be available for you to configure and to monitor the data from. Let's say we've just added a device here. If I go over to the data view, you can see that we can drill down into sensors. So there are sensors available from the gateway itself to do with CPU temperature, network traffic, whatever other sensors are on board, or from the nodes that you've joined, and they can all be accessed here. So you can pull up a feed of data. Let's pull this one up, make it purple, whatever. And so it gives you quick access to all of the data in the system. And this isn't intended to be a detailed data analysis tool. Again, this is for the install team or the operations team audience to make sure the system is producing data the way it should, but it's not intended for regression analysis or like any kind of heavy data analysis. That's the job of our partner software platforms or the partners that we work with, and we're not trying to do that job badly. Our role in these projects is to get data very reliably and securely from point A to point B, so our partners and their engineering or data analysis teams can make use of it in some way and add value to it. I'll just talk about our approach to setting up interfaces to third-party platforms briefly. So I showed you the dashboard that's exposed. In this case, what happens to make that dashboard possible are what we call flows. So flows are interfaces that are pre-built to partner platforms. We have a bunch of them built already for all of the leading energy management or demand response software platforms, and it's really easy to build new ones and to add new ones to the system. So you can build one of these flows, a software development team or our team can build one of these, version control it, release it, and then it's a .edge file that you drag and drop on here, and that sets up communications to your software platform of choice. And I'll just show you what it looks like under the hood. What we're looking at there is the front end of Edge, and I can also log into the back end of Edge. If I scroll over here to one of these integrations, I'll pick the one that's been enabled there. So you can see that this is a drag and drop visual programming environment where you can drag pre-built components here, drop them onto your palette or designer, and link them together. This is an event-based programming environment. So something happens, triggers a piece of software to run, and then does something intelligent. But if I dive in here, you can see that there is quite comprehensive software behind each of these nodes. This has 1,700 lines of code, this one node here. And if I zoom out, you can see that you can build up very complex logic. This defines everything that happens to do with onboarding of a system. It sets up secure communications, registers itself with a cloud platform, reacts to dispatch commands, executes things locally, and exposes a custom dashboard for install teams to work with. You can get really complex, and you can start really simple with the definition of these flows. This gets bundled up into a .edge file. You drop that on here, and then you've got communications up and running to your platform in exactly the way that you need. That's flows, and also the kind of custom dashboards that they expose. Let me go to snaps next. So the operating system that's running on the gateway here is an important part of it, and it's important for a few reasons, but mainly for security and for extensibility of the platform. Some of our partners, the applications they're using our system for, need additional functionality that's not available from EpiSensor, and we're not trying to do everything ourselves. We're trying to support third-party software running on this system so that the functionality can be extended beyond anything that we would be able to do ourselves. So the operating system we're running is called Ubuntu Core, and this is a containerized operating system that has an app store baked in. Every part of the operating system can be updated right down to the kernel, and all of the software that runs on the operating system, including Edge, which you can see here, is packaged as an app and can be updated very reliably and automatically. And you can also extend the functionality by installing new apps, and this web interface gives you access to that. I can decide I want to add an app here, and one example that I pick is Olama. This is used for installing or running large language models. With a couple of clicks here, you can install an app that is able to contain and run an AI model that would run locally on the system, and you have full access to all of the functionality that app then provides. Let's say you want secure remote access to the system, and this is actually how I'm accessing this system now. This is a VPN service. This gives you remote access securely to the system from anywhere. So a couple of clicks and you can install and expand the functionality of the system from thousands of apps in an app store, either privately, like EpiSensor has an app store that contains Edge and some of our other software, and you have access to a public app store that's managed by Canonical, who produce the operating system. We're actually working on building in support for AI models running locally on the gateway. And again, this is not primarily for data analysis, but one of the challenges with these systems is that you've got people, data scientists or whatever, that don't want to know about industrial comms protocols. They don't want to know about Modbus or OPC or any of these things. That's not where their experience lies. Their experience lies in data analysis. They just want a clean feed of data. So configuring these systems is challenging in some cases. We want to get to a point where we can allow a user to upload a data sheet of a third-party electricity meter or something like that. It could be from Siemens or Schneider or ABB or any third-party device, basically. Drag and drop the data sheet and then have a conversation with the AI running locally and have it configure communications, understand what Modbus registers are exposed, what data types, what function codes, etc. that meter needs in order to set up communications with it. And then the system is able to use tools locally and then configure communications to that third-party device, and then a new node pops up in your list. That's the main use case we're targeting for AI models running locally, but there are many others. Time series data analysis is one, whatever else you can think of. So extensibility, being able to install apps locally running on the gateway to do all these kind of new and exciting things is really important. Our latest gateway is based on the Raspberry Pi Compute Module 4. It's also going to be compatible with Raspberry Pi Compute Module 5. And we're building in support for AI acceleration hardware. There's going to be a slot for a module that will interface over PCI, and it will expand the hardware capability. So we're going to have options to expand the hardware capability and the software capability with the App Store. You need beefy hardware to run AI models locally, but our approach to that is these drop-in modules provided by Raspberry Pi or others that provide GPU locally. In terms of resource sharing, so that's really important that you don't populate so many apps or load the system so much that you break it, and the operating system handles that. So having all software containerized with specific access granted to resources is really important for that. Of course, you can max out the capability of the hardware if you try, but the hardware we're running on, you can consider it capable for all kinds of getting data from A to B type use cases. If you want to run AI models locally, we're going to offer an expansion slot for AI hardware modules like Halo to drop in there and expand the capability of it. That's the plan. Finally, I will show you some of the automation capability. We provide a bunch of automation capability, and some of this is still in development, but out of the box, where you've got relatively simple control mechanisms. If this happens, then do this thing. And then you can also implement more complex control algorithms using the approach of flows. You can define custom control and automation using flows just by dragging and dropping components and writing software. For complex use cases beyond what we provide out of the box, you can take that approach. But I'll just show you what we provide as standard. If I add an automation to the system here, it can be triggered by data, status, or on a schedule. So if I click data, you'll be guided through this process with kind of a wizard or whatever you want to call it. I have 3 different options for a data-driven automation. Let me pick limit. First of all, it's asking me to select a source, select a sensor in the system that would drive this automation. I've just picked relative humidity there as an example. So let's say I want relative humidity. I want to do something when relative humidity is greater than 90%. And maybe I want to do something when it's also lower than 30% or something like that. And let's say I want to execute that immediately when that condition is met. So I'll continue on here, and let's say I want to take a simple use case to send an email. And let's say I want to send an email not just to one user, but everybody in the system that's been tagged with engineering. So you can send an email to a group of users. And let's say I want automatic content, so that will generate something like relative humidity on sensor ID, whatever, which is on this node has exceeded a value of 90% at this particular time. And then I can continue, and that automation, give it a description or whatever, and activate it. That automation is ready to go. So they're the kind of automation features that we support out of the box. Status as well. Let's say you wanted to get some kind of alert or notification when the status of a node changes. So if it goes offline or somebody plugs out some of the infrastructure or whatever, then I can pick a node in the system, continue on. I want to do something when it's offline. I want to send an SMS to a specific user, myself, who's an admin, so I can continue with that and set up that automation as well. So that's a status type automation. Or I want to do something at a particular time. A flow is treated like a node in the system. If you look at this one, for example, you can see some data that this custom flow is tracking. So this is tracking the number of MQTT messages that are sent out to this particular software platform over time. And you can see a spike here, and maybe that's interesting in terms of troubleshooting the system. You can trigger automations based on data that originates in a flow, or originates from a node, or originates from a sensor on the gateway itself. If you need some automation capability beyond what's available here in these kind of standard boilerplate templates for automation, you can do that by developing software within a flow, but it would be separate to what you see here. So it would be bypassing this standard functionality and giving you access to the full capabilities of the system, and you can write software to do whatever you want, communicate with whatever third-party service. An example might be, I don't know, taking a pricing signal from a grid operator, or taking weather information or something like that. And that's possible with custom flows. I'll just show you the settings available briefly. You have a lot of settings and monitoring capability. You can look at logs, you can download log archives, you can configure watchdogs and users and notifications and tags, and all this stuff is configurable. In this interface, I can add a user here, set a password, give it a role in the system, full or read-only access, assign tags to it, existing or new tags, email and phone if you want to enable notifications. Everything you see here is configurable under the surface. And beyond the web interface here, you can actually do everything we're doing through the web interface now through an API. There is separation between the front end web interface and the back end. If you want to do anything programmatically, if you want to automate things, some of our partners use this API for configuring a system automatically. So you can write a script that communicates with the API of Edge and runs through a sequence of setup procedure or whatever, maybe to configure a cellular connection or a SIM card. You can automate everything that you see me do here through the API. Network interfaces, what we're trying to do is to avoid users having to switch from one web interface to another, to a shell or console or whatever. We want to give you all of the configuration capability you need from a single web interface, because that's a much better experience. So you can configure Ethernet interfaces and cellular connections and Wi-Fi and whatever else. You've got network, operating system, the snaps or apps that would be installed, custom flows, adding nodes, all of that. Everything you would need to extract data out of an environment and set up control capability available through the same web interface. And yeah, that kind of covers the main features of Edge. Hopefully that gives you a bit more insight into what it can do and the role that it can play in projects.